Today I'm going to talk about electromagnetism. The minor topics that we use is magnetic flux. First, you can know that what is magnetic flux. Magnetic flux is the line of force that has a given area, just like the picture. The greater the number of magnetic field lines that pass through a particular area, the greater is the magnetic flux through the area. This is the area that we talk about, and this is the formula of the magnetic flux is equal to BA, which is B is magnetic field and A is the area. The unit of flux is Weber, and the unit of magnetic field is Tesla, and area is meter square. If the given that didn't give you directly meter square, you must change into the meter square before you calculate it. This is more about equation magnetic flux. This is so easy. Let's do the same thing we do. So let's find the given first. Given is the magnetic flux through the loop of area A is 0.05 Weber. When the loop is perpendicular to the magnetic field of 0.1 Tesla. For what value of the magnetic field will the flux through the same area? Through the same area, so it means A1 is equal to A2. So area is 0.2. Here is all given. First, let's write the formula. Use flux number 1 for the initial flux. This is equal to 0.1 A1 is A2 is equal, so we just write it, we don't know A1. Let's do some mathematics. This is A1, but we said A1 is equal to A2, so let's do the same thing. The question is asked for the value of magnetic field, which is we need to find V2. Let's start it. Two is 0.2, B2 we don't know, and A2 is equal to A1, which is 0.5. Do some mathematics thing. So B2 is equal to 0.5 over 0.405. Example that about the question. This question is about the magnetic flux that we just talked about. So let's start with what is given. Given is give us 100 centimeters square each area. And here 0.2 Tesla is B, magnetic field. The question is asked to find what is the magnetic flux passing through this coil. So it's asked for flux. Before we calculate it, just remember that the unit of area is centimeter now. We must change into meter before we calculate it. Centi is 10 to the power negative 2, but this is square, so we must times 10 to the power negative 4. After that, we can use this to calculate in the formula. which is equal to, don't forget your unit, and that is
Mr. Dan, my name is Prigyanwana. I'm from 5A, number 11. Today I'm going to talk about electromagnetic inductions and also Faraday's law of induction and Lenz's law. These pictures is an examples of electromagnetic inductions. These red lines and the magnetic lines of force which travel from north to the south. Electromagnetic induction, or sometimes just induction, in a process where a conductor placed in a changing magnetic field or conductor moving through a stationary magnetic field causes the production voltage across the conductor. This process of electromagnetic induction in turn causes an electric current. It is said to induce the current. So next we're talking about the Faraday's law of induction. EMF equals to numbers of turns times magnetic flux over times. Faraday's laws of induction is a basic law of electromagnetism, predicting how magnetic field will interact with an electric circuit to produce EMF. Faraday's law of induction states that the electromotive force induced in a conductor is proportional to the rate of change of magnetic flux linkage through the conductor. So let's see the examples. The magnetic flux passes through a 500 turns coil in radius from 4.0 times 10 power of minus 5 to 2 times 10 power of negative 5 in 2.02 seconds. What is the average EMF? So the number of turns is 500. Magnetic flux is, the changing of magnetic flux is 4 minus 2 times 10 power of minus 5 is equals to 2 times 10 power of minus 5. The changing times is 0.02 seconds. So next we put formula in and substitute the number. 500 turns times 2 times 10 power of minus 5 over 0.02 seconds, which I already calculated is equal to 0.5. Next we talk about Lenz's law, which is a little bit of change from Faraday's law of induction, which is a negative sign in front of n. Everything is in the same. Lenz's law, named after the physicist Heinrich Lenz. The law states that the direction of currents induced in a conductor by changing magnetic field due to the Faraday's law of induction will be such that it will create a field that opposites the change that produced it. When an EMF is generated by a change in a magnetic flux according to Faraday's law, its polarities of the induced EMF is such that it produces a current whose magnetic opposes the change which produces it. The induced magnetic constants inside any loop of wire always act to keep the magnetic flux in the loop constant. This is the end of electromagnetic induction. Thank you for listening. Bye.
This is generator. It is a device that converts mechanical energy to chemical energy. Electrical energy. The mechanical energy can come from combustion engine, turbines, or several more ways. This is basic principle of the generator. The force, the torque is exerted here to spin the armature coil through the magnetic field and produce a current. And then this is the output. The voltage is come out through the slip rings. This is for the AC electricity. If you want to produce DC, just replace slip ring with commutator. The first generator is produced by Faraday. The device is called Faraday rings. It is produced in 1833. That's it.